Okay guys, welcome back. This first video we're going to go through the generation of the structural geometry in Rhino and Grasshopper. If you're familiar with this type of things and you just want to get started with the space gas analysis plugin package, then you can skip to the next video where we start to delve into space gas. If you're new to Rhino and Grasshopper, this video will be quite good for you. We're going to go through step by step how to generate the structural geometry for the small pavilion that I showed in the introduction video. So it's a reasonably simple process. We're going to look at a couple of we will manage, well, as we go through, we'll start to look at some of the ways that we set up tree structures in Grasshopper to better manage or allow us to have more control over specific elements and element hierarchy in a structure. But for now, let's get started. I'm using Rhino 6 and Grasshopper, which comes inbuilt with Rhino 6. I'm doing this project in millimeters. There's no specific Rhino file that you need to work with this. Everything we do is going to be generated from Grasshopper. We're literally just going to be using Rhino as a visualization tool. Okay, so let's get started. So the first thing I'm going to do is go back to my plan here. And the first thing we need to do is generate this oval shape, which is going to set out the base curve for our overall structural geometry. To do that, I've constructed a point in Grasshopper, and I can give that point an X, Y, or Z coordinate. At the moment, I want it to be at the 0 plane, so I've got a point with 0, 0, 0, 0, 0. Now, there's a component in Grasshopper which allows you to generate an ellipse, and this is basically going to be our oval that we're going to define. I'll just zoom to the oval that we can define by two number sliders. So a number slider along in the X direction, a number slider in the Y direction. So you can see here, I can start to manipulate this oval. Now, what I want to be able to do is set the point, which is an angle from my x-axis, because I might want to be able to position this, the pavilion around somewhere on this oval, and I might want to position it. I might need to, I guess, run some sunlight optimization, and I might want to be able to position it in the best space or in the best location to, I guess, get the best shading for the people that are going to be underneath it, or whatever. So, and that might come from someone else, but we need to have that ability within our script to do it. So what I can do is project a point onto this ellipse. So you can see here, once I've imported my point and my radiuses, I now have a closed planar curve, which is the ellipse. And now what I want to do is I want to project the point. So at this point is my my center point of the ellipse, which I get from my construction point. And if I just one way of understanding where these components come from is hitting the Control Alt key, and then you'll get this little information sticker on your mouse, and you can click on that to understand. So this component comes from the vector and point panel, And what that takes is my base point and the direction in which where I want that to be projected, and the curve is the geometry that I want to project it onto. So, and then what I can do is generate the direction based on an angle of to rotate this plane. So in Grasshopper, you can easily interchange a point to a plane. So if I double click and generate a plane parameter, I can easily drag this point into that, and then I can view a smaller a local plane within Rhino, and then similarly I can change that back to a point if I want to. So I'm just going to preview my plane here. So I've dragged my point into my plane, and then I can rotate this via an angle. So I've set up another number slider here, which is going to represent the degree angle I want from the x-axis. And you can see as I start to play around with this slider, I'll get an angle. From there, I can use a deconstruct plane component, and I can deconstruct the plane into the vectors that it's made up of. So in this instance, the red line here denotes the x-axis, the green line denotes the y-axis, and I'm deconstructing that to get my x-axis, and I'm going to use that as my direction to project this point. So if I turn this project point component on now, I can now see that there's a resultant point at the location that it's been projected. So I can start to move this, and I'll start to get a point running around that curve up to 100 degrees. And I can change this number slider to whatever I want. So what I want to do now is, now that I've got my point, with a closed curve, or how a lot of these curves are understood in Grasshopper, is if I just look at my endpoints for this curve, and this is another component, I'll see that my endpoint, my start and end point, is always the default start and end point when this component draws this ellipse. But to make it easier for me to, I guess, cut a section out of this curve, I want to adjust the seam of this point, and the seam is basically where that closed start and end point is positioned. And I can do that by basically using this curve seam component, which allows you to adjust the seam of a closed curve. And this component can be quite helpful, especially when you're trying to set up defined grids off a location on that curve as your start and end point. Now, in order to understand, or to do this, I need to wire in my original curve, and I also need to wire in the parameter on the original curve where I want the new seam location to be provided. In order to get that parameter location, I need to use a component called curve closest point, and you will, if you're new to Grasshopper, this is a component that you'll probably start to use a lot. And what this does is basically allows you to query a curve or query a point on a curve based on its closest distance. So, and then output output the location of that point, and then also the parameter of the curve the parameter on the curve at which or where that point is located. It also outputs a distance on how far that point is away from the curve, and in this case it's on the curve. This original point is on the curve because it's where we projected it to. So I can output that parameter and put it into the seam. And now if I wire this curve into the endpoints again, I can now see that my start and end point is now at the position of where I'm projecting that point. So my curve is being regenerated with a start and end point where I want it. And I can start to generate my grids or whatever off this now. So what I wanted to do, if I go back to here, is I want to put an input of the number of bays that I want, so the number of structural bays, and then also the length of the bay, the length of each bay. And I'm going to use that to drive, I guess, the width or total length of the structure. So I've set up two number sliders here with those two inputs, and I've got a bay width and a number of bays. And I'm simply going to do a multiplication of these two numbers, and this is going to give me the total length of the structure. So again, there's a lot of, if we go to the math tab, there's a lot of numerical operators that you can use for addition, multiplication, subtraction, division, and I'm doing those here. So I'll just run you through this logic here. What I've done is I've got the bay width and the number of bays. I've used a multiplication component to multiply those two numbers together, which will give me a result of the total length of the bay. And then what I do is I divide that by 2, and that's going to give me basically half of the bay, or half of the length of the structure, obviously, because at the moment my center point is the point in which I'm projecting for the center. I'm taking the, and then what I need to do is basically get the, I need to shatter that curve. So I only want a sub-segment of the overall ellipse. So in order to do that, I can take my ellipse curve, and I'm going to wire that into a curve length component. And what that does is generates the length of the ellipse from the start to the end. And then I'm just going to subtract the half width of it to the overall length. And I'm going to put that number in a merge component, and we'll use merge components quite a lot, and what that allows you to do is basically add bits of data together based on their tree structure. Now, because we've only got one item here and another item, we'll just it'll just result in 2 items. So basically, I want to take, I want to have a point at the length, or half the length from the start, and then half a length from the end. So that's what I'm doing here of that curve. Then I can use an evaluate length component, which allows me to get a point at a length along that curve. And if I turn that on, you'll see that I've got 2 points now on that ellipse. Now, the way that Grasshopper works is if I have one curve here and I have 2 lengths, it will perform that operation for that same curve. So you'll see here I've got 2 points. Right, so from there I can get the parameter at which this length is provided, and I can use this to shatter the curve. Now, shatter the curve basically means split a curve into segments along at a specific parameter. And you will use this component a lot as well if you're dealing with beams and sections of beams. And that can be found under the curve division panel. So that takes in my original curve and then the parameter at which these 2 points are located. And that will output, I guess, the two sections, the two segments of the curve. So when you click on that, you will see the entire curve. But if you can then get, I guess, a list item component which allows you to take an item from a list. So I've done this, and I've done this using the zoomable component. So if I zoom in on this component, I can actually zoom in and it will allow me to add and retrieve items from here. So I is by default the index at 0, but I can use these zoomable components to add. So this is +1, so plus I. Alternatively, I can just create a panel with the index I want and place that in there. So if I click on this component now, I'll see the segment of the curve which I want to use. And this is going to be the base curve in which we generate the rest of our structure off. And if I go back to the first couple of inputs, I can now see as I start to move this, as I start to move or change my degree, my original degree input, I start to get that, I can get that curve moving. I can also obviously change the bay width, and I can choose my number of bays, and my curve's going to automatically update. And I can also obviously change my ellipse to get a different oval shape. Now, the reason that I've chosen to, I guess, get this base curve is when we start to generate plane intersections later on, you can run into problems when you have, I guess, a closed curve like this, and we'll go through that in a little bit more detail as we move forward. You also might set up this curve as a bit of a placeholder if you're waiting on, I guess, set out information from an architect or a landscape engineer, and you might want to plug in, I guess, a more defined curve at a later date once you have that information without affecting your, I guess, your overall script. Okay, so let's just move forward now, and what we're going to do is set up the generation of the structural, or start to look at the structural arrangement. So I'm just going to enable that, and in order to do this, we're going to go back to our section here and start to look at how we're going to define this. So if we've got the center, or this is our set out point for our structure, we've got two main variables here, and the first one is our backspan, and the second one is our cantilever. And in order to do that, we're simply going to offset a curve from that distance, and then offset another curve to get the set out of the backspan. We're also going to provide variables for our backspan height and our cantilever height, which is going to basically set the angle the angle position. Okay, so I'll just quickly go back to here. So basically what I've done is set up a bunch of panels and name these panels with these inputs. So I've got a backspan height, I've got a front height, which is the height of the cantilever, and I've got my cantilever offset, my backspan offset, and then also my tie offset. So if I look at this, and that is the offset where my backstay is going to come in. And this backstay offset is based off my my offset backspan curve, which we'll have a look at. So it's not separate. And the reason I've done this is if you do this separately, you might run into problems as you update this backspan. It's not. It could affect the geometry as you try and manipulate these backspans or whatever. And then I've also added some other parameters here, which for my plinth height and my and the purlin spacing that I want to, but we'll look at those in a minute. So I've got my base curve here, and the first thing I want to do is offset that curve, and I'm using an offset curve component, and I can typically specify a distance I want to offset that curve, and I can use a negative distance as well, and that'll just decide which side of the curve I offset by. So I've offsetted my cantilever by 10 meters at the moment, and I've also done the same thing for my backspan, and that's creating my backspan curve. And then, as we discussed, I want my the line for where I'm going to set out my tie or my backstay element, and I'm going to inset that 600 meters from my offset backspan curve. Okay, so those are the main, those are the three, or I guess the ground level base set out curves, and from there I want to apply my my cantilever height to these and my backspan height. So what I can do is use a move geometry component, and this allows me to move geometry via a specified vector. So I can create, and you'll use these components quite a lot, is a unit Z vector, and basically this generates a vector in the Z unit in the world Z direction for a specified factor. And in this case, for my backspan, I'm going to want this to be 2.2 meters or off ground level, and for my front height, I want it to be 4.5 meters. And I can change or update those as I want. So I'm going to wire in my cantilever curve into this move component, and if I go to the perspective preview, you can now see that curve has been moved up that specified distance. If I change the distance, you can see how it varies, but I'll just leave it at 4.5 for now. Right, okay, and I do a similar thing for my my backspan curve, and now what I want to do is basically generate the positions at which I want my radial sections or frames to occur. So where I want these, basically the struts and the plinths and stuff to occur. Now I can do that by using a perpendicular frames component, and what this is going to allow us to do I'm just going to turn off these components. And what that allows us to do is create frames at a specified number of frames at equal divisions along that curve. So again, if I Control Alt, I can see where this component's come from. So it's in the curve and division. And I'm providing my count from my original variable input from the number of bays that I want. And what I can do basically to set up how I'm going to generate, I guess, these frames at each sections, there's a lot of intersection type components which allow you to intersect all different types of shapes. But here I'm going to use the curve plane intersection component. So it's in mathematical curve plane intersection. And what this perp frames component output is a whole bunch of basically planes, and you can see those there if I click on them. And what I can do is I can drag my curve, which I want to intersect that plane with, into the curve parameter, and the list of planes in which I want to intersect, or get the point at which they intersect. Now, this is the first time we're going to be, I guess, stepping into trees. And you'll see if I hover over this points component, what it is doing is it's giving me basically a tree branch of every point along that curve. Now, the reason that it's doing that is because this parameter takes one item and the plane input takes one item. So it's giving me a result for every one of these plane items. And that is kind of what we want, because it's going to allow us to manage individual sections in a more efficient manner. So if I just click a panel component here, you'll see that I've got a branch, I've got a point at each branch, and I'll just turn this component on, and you can see these here. Now, I might want to, I guess, flatten this to generate a list, and I could use a flatten tree component. And to understand the difference between this, I can drag that in, and you can see I've got a list there, or I've got this. And to understand the difference between these, I'll just do a quick point list component, and what this allows me to do is visualize the number of that point in the list. I'll just set that to 50. Bigger. So if I've got a flattened tree, I can see 0, 1, 2, 3, 4. But if I drag in my branch trees, I'll see 0, 0, 0. So this is a list of lists. And what I'm going to do is do the curve plane intersect for the other primary curve. So this is the cantilever edge. This one here is the backstay curve. This one here is the inset, so the base of the backstay. And in order to get the base of the concrete plinth, I don't need to do that curve intersect, because this is where I'm getting my frames from. But I don't really need that to be a plane. I just want that to be a point. And I can basically use a component here to generate my concrete plinth lines, and I'm using a line SDL, and that basically means a start point, a direction, and then a length of the line. So, So from there, I've got my direction, which is a vector, and that's a unit Z, and then I'm going back and I'm using my plinth height to generate the length or height of that element. So I can then use that and that generates, so that will actually generate a list, because this direction or this length allows you, or this allows you to import a list. So that's a list of points, so it's basically generating a list of lines. Now, what I want to do is, in order for my data to be structured the same, is I want to make sure that I graphed this list, and I can right click on the line output there and select graphed. And what that will do is change it from a single list to a similar tree structure to how my curve and plane intersections have come out. You'll see that there's a whole bunch of zeros at the front there, whereas here I've just got 0, 1, 2. And what I can do is I can right click again and simplify, and that will reduce it to its simplest tree structure, which is that. So now we'll see that we've got basically these points which we're going to start to generate our members and stuff off.